Hello guys, welcome back to another Gregorius Maths video. Today we'll be looking at the Maclaurin series expansion and then using that to find out e to the ix and e to the I pi. So, if we have a function which is infinitely differentiable, f of x equals the sum as n goes from 0 to infinity of Cn x to the power of n. So just some coefficient and then we'll put some index n times x to the power of n. So if we rewrite this is equivalent to saying C0 times x to the power of 0, which is just 1, plus C1 times x to the power of 1, plus C2 times x squared, plus C3 times x cubed, and so on. Okay. Now that means that f prime of x equals, C0 is just a constant, that will vanish, C1 plus 2C2 x plus 3C3 x squared plus f double prime of x equals, C1 is again just a constant, so that will vanish, 2C2 plus 3 times 2 C3 x to the power of 1 plus and now if triple prime of x equals, 2C2 is just a constant again, 3 times 2 times 1 C3 plus and I could keep going down forever and ever because we've already established that this function is infinitely differentiable. So now to solve for Cn, we'll look for a pattern. So when we didn't differentiate it at all, this C0 here is the same as saying 0 factorial times C0, right? And then this C1 is the same as saying 1 factorial times that. This 2 times C2 is the same as saying 2 factorial times C2. And this 3 times 2 times 1 is just 3 factorial. So, Fn of x equals, hold on. So to solve purely for Cn, we have to set these x's equal to 0. So f of 0 equals 0 factorial times C0. F prime of 0 equals 1 factorial times C1. F double prime of 0 equals 2 factorial times C2. F triple prime of 0 equals 3 factorial times C3. So, if we differentiate this function n times at 0, we get n factorial times Cn. And now it's simple to solve for Cn, divide both sides by n factorial, leaving us with Cn equals f prime, so differentiating fx n times and then plugging in 0 over n factorial. So now we can plug this into here, meaning f of x equals the sum as n goes from 0 to infinity of this is just the same as Cn, so fn 0 over n factorial times x to the n, like there. Well, okay, so now I'll use this fact here to solve for e to the ix. So I'll just rewrite this at the top. I might need some space. Goodbye working out. sum then goes from 0 to infinity of n of 0 over n factorial times x to the n. Okay, so because we're looking at e to the x and okay, so hopefully some of you guys know that this equals cosine of x plus I sine of x. So I'll preemptively write the Maclaurin series expansions for sine of x and cosine of x. So, but first, e to the x equals, well, it doesn't matter how many times you differentiate e to the x, you'll just get e to the x. So fn of e to the x, not ex, e to the x, that's just, well, if we plug in 0, basically if we plug in 0 into our x, we'll always get 1. So it's 1 on the top, 1 over n factorial times x to the n equals x to the n over n factorial. So this equals the sum as n goes from 0 to infinity of x to the n over n factorial. And that's where we get, say, if we plug in 1 for our x, for example, we'll get 1 over, the sum as n goes from 0 to infinity of 1 over n factorial, which is a very common definition for e. But this holds for any x, okay? And then for sine of x, this equals the, well, no, okay, so, sine of, okay, so, d dx of sine x equals cosine x, d dx cosine x equals negative sine x, and then derivative, and then, okay, that's enough, that's all we need to know really. If we have negative cosine, that's positive sine. If we have negative sine, that's negative cosine, okay? So, sine of 0 is just 0. So, for every even term, we'll just get 0. So, the derivative of sine is positive cosine. Positive cosine of 0 is 1. If we plug in 1 into our n factorial, we get 1. So, we get 1 over 1 factorial times x to the power of 1. So, we get x overall. We just get a lot of 1s and then times x. Plus, well, for every even n we get 0. But it's important to note whether it's negative sign or positive sign. Well, in the last one we had positive, so cosine, negative sign. So negative sign. Derivative of negative sign is negative cosine, so minus, plug in 0, we get 1. If we plug in 3, we get 3 factorial x cubed. We get x cubed over 3 factorial. Again, this time we had negative cosine, so it's positive sine. But then again, it's just 0. And then for the fifth derivative, it's just positive sine, so it's plus x to the fifth over 5 factorial. Hope you can see the pattern. And then minus x to the 7th over 7 factorial, and then da-da-da. You can check my working if you want. And then cosine, x, well again, we've got everything we need to know, equals. But this time, because cosine is an even function, every time we differentiate it an even amount of times, it'll be cosine. Basically, the first term will be 1 over 1 times x to the power of 0, which is 1. So just basically just 1 times 1 times 1 times 1 a lot of times. And then f prime of 0 is negative sine, but sine of 0 is 0, so everything will become 0. The derivative of negative sine is negative cosine, so minus. Now we plug in 2. We get, okay, so when we plug in 0, we get 1 over 2 factorial times x squared. So x squared over 2 factorial. And then we just had negative cosine, so negative, negative, positive sign, 0. And then we'll go in for one more term, plus positive sine, positive cosine, 1 over 4 factorial times x to the power 4, x to the power 4 over 4 factorial, then minus x to the power 6 over 6 factorial. Okay, so now if we plug in ix into our x here, we get e to the I x equals the sum, it then goes from 0 to infinity of ix to the power of n over n factorial, or ix to the power of 0 over 0 factorial plus ix to the power of 1 over 1 factorial plus ix squared over 2 factorial plus ix cubed over 3 factorial plus ix to the 4th over 4 factorial. We'll just write one more term, plus ix to the power of 5 over 5 factorial. Okay, that should be enough terms. This just simplifies to 1 plus ix over 1 plus ix plus I squared is negative 1, so negative x squared over 2 factorial. So actually it's a minus x squared over 2 factorial plus I cubed is negative 1 times I, which is negative I. So actually it's minus I x cubed over 3 factorial plus I to the power of 4 is 1, x to the power of 4 is x to the power of 4 over 4 factorial, and then I to the power of 5 is just 1 times I, which is positive I, so I x to the power of 5 over 5 factorial. And now if we separate the imaginary and the real parts, we get 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial plus I times x minus minus is minus x cubed over 3 factorial plus x to the power of 5 over 5 factorial. And now if we trace back, we get cosine. This is all equal to cosine x plus I times sine x. Okay, now if we plug in pi, cosine of pi is negative 1, sine of pi is 0, so we get e to the I pi equals cosine pi, which is negative 1, plus 0. So e to the I pi equals negative 1. And that's all I wanted to do in this video. Thank you guys for watching. Hopefully you learned something new. I'll see you in the next video. Bye.